Having now laid the foundation for what a vector and scalar quantity is, we can start getting more geometric and mathematical definition behind what they are. So let's say that this is the Atlantic Ocean, and I've superimposed the coordinate grid over the Atlantic Ocean. Then this is the y-axis, and this is the x-axis. So let's say there exists two islands in the Atlantic Ocean. I will call this island P, and we'll call this island Q. And say I want to get home to island Q over here. I live on island Q, and I'm currently on island P over here. And I ask one of the islanders, I say, hey, I want to get home to island P. What should I do? They're going to tell me, well, you should move, obviously, in the direction of point P. And they're going to tell me some distance to sail. Some distance to sail. And that distance to sail is, of course, the length of this arrow. And they're also going to give me a direction to sail, right? I can't just sail off over here, right? I have to go towards point Q. So they're going to give me a distance. They're going to give me a distance to sail. Distance to sail. And they're also going to give me a direction. Maybe they'll give me an angle or something like that. They'll give me a direction, a heading, as a better definition. So if they're giving me a distance, that's the distance from here to here, and they're giving me a direction, what are they giving me essentially? They're giving me a magnitude. We can cross this out. We can rewrite this also as a magnitude, the distance to sail. And they're giving me a direction. And let's think about last video, right? They're giving me a magnitude and a direction. They're giving me a vector. They're giving me a vector to get home. So we can characterize this. This is a vector PQ, if we were to think about that. It starts at point P over here, and it ends at point Q. So if we were to think about this vector, we can denote it with some kind of a notation. We'll call this the vector PQ. PQ. It starts at point P and it ends at point Q. So that's how we denote vectors. That's how we're going to denote vectors in the remaining of this course. So now let's get a little bit more math behind this. Let's say now that island P, let me just delete these real quick. Okay, let's say island P is at the point 1, 1, 1, and point Q is at the point 4, 2. So this is over here. This is the point 1. This is the point 1, and this is 4. And this just about is 2. Sorry, this is not the scale. I'm just trying to get an idea going here. So now, what if I wanted to find the distance between these two islands? I really want to get home, so I want to make sure I know. I want to make sure if just how far apart they are. So when I sail, I'm essentially going to move in this direction to the right, and I'm also going to have to move upwards a little bit. Let me move that over a little bit in order to get home. That's going to be my relative motion. I could take one straight shot from P to Q. I could also go to the right and then go up, but obviously I'm just going to go straight from P to Q. Now, I said I want to find out the length. I want to find out the distance between point P and Q. What if I can use Pythagorean theorem? So the length of this leg right here, what would be the length of that leg? That would just be 4 minus 1. That would be a distance of 3 units. This distance over here would be 2 minus 1. That would be 1 unit. This is a 3. Sorry if that was unclear. You write that better. This is the distance of 3. So now, yeah, what's this? We'll call this C. Well, we know from the Pythagorean theorem that C is equal to the square root of, in this case, it would be 9 plus 1. So C would just be the square root of 10. So I would have to sail square root of 10 units from P to Q, but in what direction, right? That doesn't tell me how to get home. I can sail square root of 10 directions and square root of 10 units in that direction. So I need a direction. So how can we characterize the direction of this vector? Well, what if the islander gave me some angle theta? Well, I know this is a distance 3. Oh, I already wrote 3. So This is a distance 3. This is a distance 1. I could use the inverse tan function. So the inverse tan of the opposite over the adjacent, that'd be arctan of 1/3 units, 1/3. And this gives me some angle theta. So notice, this is the magnitude. The magnitude is the length of this vector. And the angle gives me the direction to sail. And this is relative to the horizontal, relative to the east direction. So the vector is telling me to go square root of 10 units at an angle theta of arctan of 1/3 north of east. Northeast, if you want to say that, north of east. And this is how I would get home, is using this piece of information here, this quantity. This is what the villagers would give me to go from P to Q. So hopefully that gives you some intuition behind what a vector is in a more mathematical description.